Hi guys, it's Miss Aguilar again. This is the second video, and the first video is really short because I tried to do it at the end of my prep and I ran out of time. Anyways, so let's just pick up where we left off. I'm talking about the work and power equations. So the equation for work is force, that's a capital F, times distance or displacement. Don't forget that when you're trying to do these problems that it won't typically give you the force. Maybe it will give you the mass of somebody pushing something, and in order to figure out what that force is, you just take the mass and multiply it by gravity. Power is P is equal to work over time. So how much work is done over a certain amount of time. You can just take this equation from here and make that all work. Oh, okay, let's do the units. The units for work are watts. The units for power are watts. The units for work are joules. And you know for time it's seconds. For this one over here, we have joules. We have newtons times meters for the one on work. The wave equation, we have velocity is equal to the wavelength. Remember, this is that lambda symbol. And then multiplying that by the frequency. The units for this are meters for every second for the velocity and hertz, sorry, that's capital H, for wavelength and, meters for wavelength, hertz for frequency. That's a Z. All right. All right, so we have the frequency and the period. Remember, frequency is just the number of cycles for every 1 second. And then period, capital T, is the number of seconds for every 1 cycle. In order to use these equations, like maybe you have T but you need frequency, it's simply the reciprocal of period. Maybe you have frequency but you need the period. To solve for the period, it's simply the reciprocal of frequency. All right? Okay, so here are some projectile motion problems. Actually, this is one projectile motion problem. It says, on the last day of school, Jackie and Aaron decide to throw their physics textbooks off the top of the stairs. If they project the textbook at a height of 12.2 meters with an initial horizontal velocity of 9 meters per second, how long does it take the textbook to reach the ground? Okay. So these projectile motion problems are pretty intense, or a lot of detail, and it's only just to keep you organized. I always start off with a list of knowns and unknowns for the x and the y components, and you guys know how to do this. We have delta x, velocity in the x, t. We have delta y. We have velocity in the y, g, and then we have t. I'm going to put t over here. I'm running out of space. So we have a couple of values here. A height. Height, when you see the word height, you should obviously or automatically know that it goes in the y because y is vertical, up and down. So we have 12.2 meters. And then we have a horizontal velocity, and that's the x direction of 9 meters for every second. We know gravity, this is a g right here, that's 9.8 meters per second squared. Time we don't know, and that's what we're trying to figure out. How long does it take? So in order to figure out how long it takes, we can use this y equation because we have 2 known variables. So we're going to use the t is equal to the square root of 2 times delta y divided by g. Okay, and then what do we get when we do that? Well, first we have to take 2, multiply it by 12.2 because that's our delta y. This is all under the square root divided by 9.8 meters per second squared. This is meters. And then we do the math, right? So 12 times 2, or 12.2 times 2, 24.2. You have it under 9.8, and it's all in the square root. Once you divide 24, oh, it's 24.4, I'm sorry, you guys. 24.4 and divided by 9.8, you get 2.49 meters, per second squared. Okay, so we want just in seconds, so we have to get rid of all that stuff. After we do the square root, it ends up being 1.58 seconds. And that is your time. Okay? All right, so down here it says, how far did the textbook travel horizontally from where Jackie and Aaron threw it? So we now have our time. And remember, we can use time on both sides. If we solve for time on one side, it's automatically then solving for the time on the other side because it's the same time. How far did the textbook travel horizontally from where Jackie and Aaron threw it? We're trying to figure out delta x because delta x is the change in position in the horizontal direction. And that equation is velocity of x times t. We have the horizontal velocity, it's 9 meters per second. We just solved for time and we came up with 1.58 seconds. If we multiply the two, sorry, hold on, let me get my calculator. So if I take 1.58, multiply it by 9, I get 14.22. So 14.22 meters. That is the answer for B. All right, I know, short and sweet. I'm going to end there because I'm at school and the bell's going to ring. All right, guys, don't worry. I'll keep going with these videos. I know we've already gone over this, but just in case you forgot them, they're here for you anyways. All right, have a good day.